redo the intro slide in case you're watching this first. All right. So uh, time complexity tells you how tells you the running time, how it depends on the size of the input. So it's a function that takes, here's a function, t of n. It takes the size of the input in and maps it to the time executed, right? And I like to think about size as being um, how much work uh, I have to do to give you the instance, or equivalently, how much work you have to do to read the instance. And time is how much work you have to do to solve it. So time complexity says the relationship between how much time it takes me versus how much time it takes you. All right, so here's the part that I'm adding. Suppose we have uh, three values. So here's the set of values that n might take on. It might be 3 or 4 or 5. Here's the set of values that capital N might take on. And we're going to talk about functions between them. So the blue little n is a function, here, this arrow here, that takes capital N as input and returns little n. And in this case, it's little n is the log of capital N. So this is a function. And you can see the log of 8 is 3, the log of 16 is 4, and so on, right? And then we can talk about the inverse function. See, this blue here is a function that takes little n as input and returns capital N. And so you should know that the inverse function is exponentiation. 2 to the 5 is 32, right? So that's the inverse function. It maps in the opposite direction. Right, let's do it again. Capital blue t is a function from capital N to capital T. And in this case, it takes the capital N and squares it. 8 squared is 64, right? And so the inverse function, going the other way, takes the t and square roots it to get the capital N. All right, so now we can compose. If we want to get the function from little n to capital T to t, here capital T is blue t. Blue t is a function from little n to capital T. We compose by going from little n to capital N to capital T, right? So how does that work? Well, get from how do we get T from, how do we get T? Well, we get T from N using this N squared. This is how we get T from N squared. And then how do you get N squared, capital N, from little n? Well, that's uh, an exponentiation. So here we take little n, we exponentiate it to get capital N, and then we square the capital N to get t. It goes from here to here to here. It's the function from little n to capital T. And similarly, we can get the function that takes capital T uh, this way, right? Um, so how do we get little n? We take the log of capital N. How do we get capital N? We take the square root of t. And so those are all the functions going in various directions. Now, why do we do them? As well, we might know some of these functions, but we want to know the other functions. So, for example, capital N might be a value that we just don't want to think about because we think it's bad. On the other hand, little n we use to denote the size of the input. T we use to denote the time executed, and hence the function from little n to capital N is what we call time complexity. And now we're going to talk about different models of time complexity depending on what our definition of the size of the input is and what our definition of time is. And you can go on to the previous